Hi everybody. So in this first video, we're going to look at how to complete the square. So this is something that you may have seen before, but we're just going to take a quick review of how to do this because this is going to be really important throughout this whole unit, okay? All right, so to start with, let's take a look at example one, and we're given three different trinomials. And the first thing I want to do is just factor. So of course, remember when we're factoring for part A here, we're looking for numbers that multiply to 9 but add to 6. So of course, if we factored that, we would have x plus 3 times x plus 3, or that would just be the same as x plus 3 quantity squared. Okay. Similarly, in B, we're looking for numbers that multiply to 25 but add to a negative 10. So that would be x minus 5 times x minus 5, or x minus 5 quantity squared. Okay, and then lastly in part C, we're looking for numbers that multiply to 100 and add to 20. So that would be x plus 10 and x plus 10, or equivalently x plus 10 quantity squared. Okay, so the reason I want you to take a look at these is all three of these have something in common, and that's of course that all three of them are perfect square trinomials, meaning that when we factor them, we come out with a perfect square. So what I want to think about is, well, what makes these special so that they are perfect square trinomials? What sort of criteria do you have to satisfy in order for something to be a perfect square trinomial? And basically the relationship is going to be in the B and the C terms. So if you think about these numbers here, we have a 6 and we have a 9, okay? So something that you should notice is that half of 6 is equal to 3, and 3 squared is equal to 9. So in other words, if we take 6 and divide it by 2, we get a 3, and then 3 squared is equal to 9. So half of the B term squared is equal to C. Okay, well, let's see if that trend continues. So if we think about part B, okay, so half of our B term would be a negative 5, and negative 5 squared equals 25, which is our C term. So that's good, that follows, okay? And then if we look at the last one, again, just to check here, half of the B term is 10, and 10 squared is equal to 100, which is our C. Okay, so this is the criteria that you have to satisfy in order to be a perfect square trinomial. Half of the B term squared has to be equal to C. Okay, so when we're talking about completing the square then, basically what we're doing is we're taking a trinomial that is not a perfect square trinomial, and we're going to add something to it in order to make it a perfect square, in order to complete the square. Okay, so let's take a look at part A in example 2 here. Okay, so right now we have a quadratic equation, x squared plus 8x is equal to 0. Okay, so right now, this is not a perfect square trinomial. So what we want to do is think about, well, what do we need to add to this equation in order to make it a perfect square? And we, of course, know that whenever we're working with equations, whatever you do to one side, you have to do to the other. So if we're adding something to the left to make this a perfect square trinomial, we have to add that same number to the right-hand side as well, okay? All right, so if we follow the pattern that we were looking at above, we would say, okay, we need half of the B term squared to equal C. So we're going to start by dividing our B term by 2. That would give us a 4. And then 4 squared is equal to 16, which means we're going to add 16 to both sides in order to complete the square here. Okay. Now, whatever number you got right here, so when you take your B term and divide it by 2, whatever number that comes out with, that's always the value that goes in your factor. So when we factor this, it's going to be x plus 4 quantity squared. Okay. All right, let's take a look at B. So same thing, we want to complete the square. Now on this one, if you already have a constant term in your equation that isn't the constant term you want to go ahead and move that over to the other side of the equation just to kind of get it out of the way, because a 4 doesn't make this a perfect square trinomial. It's not the number we need right there, so we're just moving it to get rid of it. Okay, so then we just need to think, well, what do we need to add in order to complete our square? Okay, well, again, if we take our b term and divide it by 2, we get a -6, and then a -6 squared is equal to 36. So we're going to add 36 to both sides of this equation. Okay, so again, like I said before, whatever number you get after you divide b by 2, that's the number that goes in your factor. So this becomes x minus 6 quantity squared, and then that'll be equal to 32 on the right-hand side. Okay. Oh, I just realized in example A, I forgot my equal to 16. Sorry about that. I forgot this right here in example A. All right, guys, one more example. So once again, I'm going to start by just moving the -1 to the right-hand side to get it out of the way. And then we need to figure out what to add to complete the square. So we're going to take our b term, which is a 3, and divide it by 2. Okay, so that gives us a 1.5. And then 1.5 squared is equal to 2.25. So I'm going to add 2.25 to both sides of this equation. Okay. Oops. It should be a positive one. Okay. Sorry about that. It should be a positive one right there. Okay. So then, factoring this, we're going to have a 1.5 in our factor here. So this is x plus 1.5 quantity squared is equal to 3.25. Okay. All right, guys, so that is the basic idea behind completing the square. So in the rest of this unit, we're going to use this idea when we're looking at conics. So when I say conics, what I mean is if we're looking at a cone, let me go ahead and just, so if we're looking at a cone, okay, you can take different cross sections of the cone to get different shapes out of it. So if we were to cut straight across, then you would get a circle. Or if you would cut across at a little bit of an angle, then you get an ellipse. Okay, so depending on how you cut this cone, you're going to get different shapes out of it. So the different shapes that we're going to be looking at are circles, parabolas, ellipses, and hyperbolas. So that's what we're going to be doing throughout the rest of this unit, and we're going to be using this idea of completing the square in order to solve those problems.